All right, people. I believe everybody is doing great, nice, and absolutely fine. Please let me know in the chats if I'm perfectly audible, visible to each and every single student. If I am perfectly audible and visible to each and every single student out there. And please call up your friends. We have today this important session that we will be talking about over here. And we will be talking about every single thing in detail. From the basics, from the scratch, and we say complete integration and differentiation, including the slope, maxima, minima, whatever is required for your physics, we will be discussing that over here in this particular session. So I would want everybody of you to basically like this particular session if you have not liked this session as of now, because liking the session is mandatory. Hit the subscribe button. First of all, like this particular session, okay? I would want you guys to like this as soon as possible. And tell me if I'm perfectly audible and visible, guys. Okay, and call up your friends, tell them we are starting this particular series, that is new series on YouTube itself. Great. So let the people join and we will start this session accordingly, because I don't want anybody of you to miss any of the single topics from this particular chapter. I want everybody should understand each and every single point when it comes to the integration, and we say differentiation, the complete calculus. And guys, when it comes to this particular chapter, we say in the entire physics, almost this integration and differentiation is involved. In electrostatics, there are so many questions in which we'll have to do the integration and differentiation to get the answer. Over there, if your conceptual clarity is strong, but your calculus is weak, integration and differentiation is weak, you won't be able to get the answer of that particular question. Okay? I think we need to start now. My dear friends. So let's basically start this particular journey. I would want everybody of you to understand very carefully the first topic, that is the base of integration and differentiation of calculus. That is, we say, sir, slope. Sir, till now, we have heard so many times that slope is tan theta. Slope, we can get the slope like this, we can get the slope something like that, okay? But right now, in this particular session, we will be talking about what this slope is exactly. I will be giving you the exact feel of this slope in the today's session, in this particular session, okay? So I would want you guys to listen to me very carefully over here. See, guys, when it comes to the slope, the basic and simple definition of slope is how much steepness is there. Like. If I say, my dear friends, in this particular case, I have got the two lines. This is the first line and this is the second line over here. You guys are supposed to tell me which is more steeper, this one or this one. Means which is having the more inclination. Sir, obviously this is more steeper. This is more steeper as compared to this. Sir, this is having a large steepness, very great slope. Now, sir, this is having less slope. And this is having zero slope, no slope at all. So I can clearly say that in this particular case, this is having the maximum steepness. This is having more steepness as compared to this. Okay. So we say when it comes to basically steepness, steepness is itself, we say, sir, slope. The one which has got the more inclination with the x-axis, the one which has got the more steepness will have the more slope. Now, guys, see. We can clearly see that in this particular case, the perpendicular is more as compared to the base. We say here. In this case, slope is more. In this case, slope is less. Also, you can see over here, this perpendicular is also more and base is, we say, less. But if you check in the next case, you see here perpendicular is more, but this base is less. Perpendicular is more, but the base, sorry, perpendicular is less, but the base is more. Now, can I say in this particular case, my dear friends, can I say in this particular case, my dear friends, guys, if you have not liked this session yet, I would want you guys to like this session as soon as possible. Can I say in this particular case, sir, slope is more, perpendicular is more. So I can say slope is directly proportional to perpendicular. And here slope is less, base is also less. So I can write over here, we say slope is more, perpendicular is more. So slope is directly proportional to perpendicular. And I can say slope is inversely proportional to base, as simple as that. You see here, I can say, sir, slope is less. Slope is less in this case. And in this case, base is also less. Base is also less. Here perpendicular, sorry, base is more. And perpendicular is, we say, sir, less. So slope is directly proportional to perpendicular, inversely proportional to base. Now you guys tell me, which of the trigonometric ratio has got the perpendicular by base? Sir, when it comes to the sine theta is perpendicular upon hypotenuse. Cos theta is base upon hypotenuse. But there is one thing, that is what we call tan theta. Tan theta has got perpendicular divided by base. And that's the reason maximum students directly say, sir, slope is tan theta. Why do we actually say slope is tan theta? The reason is over here. Because slope is perpendicular by base, tan theta is also perpendicular by base. As simple as that. Is this clear till over here? Guys, let me know in the chats. I would want everybody of you to tell me in the chats, is this clear? Everyone means everyone. Is this clear? Guys, give me the signal in the chats. Everyone means everyone. I would want you guys to give me the signal in the chats. Next. Let's talk about this particular graph. This is the graph between y versus x, okay? And this is a straight line we have got over here. We have got this straight line over here, that is between y and we say x, okay? Now in this particular case, if I say, I'll draw a line over here. Can I say this line on this perpendicular, on this line it is y, so I'll call this as y? Yes. And here on this axis we have x, so I call this as x. So can I say in this particular graph, this y is the perpendicular from this triangle and this x is the base? And if somebody wants to ask you that what is the slope in case of y versus x graph? So I say slope in case of we say y, slope in case of yx graph. Can I say in this particular case, sir, slope is simply, I'll say, sir, that is tan theta. And tan theta is perpendicular by base. Over here it is y divided by x. As simple as that. So we say slope is y by x over here, because on this perpendicular you have got y, here you have got x. Let's suppose if I would have asked over here, on this axis it is velocity, on this axis it is time, and the graph is something like this. In this particular case, we say, sir, slope is simply, that is, this perpendicular is v divided by, we say, t. So v by t is the slope in case of vt graph. Cool? Yes, sir. Next. Now, whenever we talk about the slope, here, I am asking you to find slope between the 2 points. Slope between the 2 points. Which point? This point over here and this point over here. You will have to tell me the slope between these 2 points in this particular case. Okay? This is the concept of slope between the 2 points, my dear friends, over here. This is the concept of slope between the 2 points. Guys, like the session, because liking the session is extremely mandatory. Everybody. Now see. When it comes to the slope between the 2 points, my dear friends, understand very carefully. Let's suppose I'm taking this point and I'm taking this point over here. This is the line between these 2 points. Okay. Can I say, I'll draw one line on the x-axis, something like this from this point, and I'll draw another line from this point on the x-axis. Okay. And my dear friends, listen to me very carefully. We say this point is at x1 distance from origin. This point is an x1 distance from the origin. And this point is at x2 distance from the origin. Means I am saying that this distance over here is x2 and this distance over here is x1. Can you please tell me what will be this distance, sir? Whole minus this, so this will be x2 minus x1. Similarly, we will draw one line on the y-axis. Let it be y1. It is at y1 distance from origin. We'll draw another line from this point at this axis. This is y2. Can you tell me how much will be this distance, sir? Whole is y2. This is y1. So this will be y2 minus y1. Now take this triangle out. Guys, listen to me very carefully. Take this triangle out. So this is the triangle, something like this. So this side is y2 minus y1. This side is x2 minus x1. Perpendicular is y2 minus y1. This is x2 minus x1. Now, if somebody asks you, between the 2 points, how much is the slope over here? You say, sir, slope is perpendicular by base. Perpendicular in this case is y2 minus y1. That is y2 minus y1. And base in this case is x2 minus x1. That is x2 minus x1. Or if we write y2 minus y1, we can also say it is delta y. If we write x2 minus x1, we can also say it is a delta x. So delta y divided by delta x, you can say it is the slope between the 2 points. We say, here, when it comes to the slope, you say it is delta y by delta x. So this is called the slope between the 2 points. So this is called the slope between the 2 points. And guys, remember, from now onwards, whenever we talk about the slope between the 2 points, I can simply say it will be simply, that is delta y divided by delta x. This will be the slope between the 2 points. As simple as that. And my dear friends, this delta y also, from now onwards, you will remember that this is also called, we say change in y divided by, we say change in x. So slope is also change in y divided by change in x. My dear friends, this delta y means change in y. If let's suppose I say delta v divided by delta t, what does it mean? It means change in velocity upon change in time. Change in velocity upon change in time. Give me the signal in the chats if everybody of you understood till over here slope between the 2 points is delta y by delta I. And what is the logic? Logic is this one that I have explained with the help of the geometry. Okay, I'll not use the red color. I'll use the some other color. Don't worry about that. Tell me in the chats, is everything crystal and clear till over here? Let me know, guys, in the chats if all of you understood every single thing. If all of you understood every single thing with the fire emojis, I would want you guys to tell me in the chats. Great. Next. So, as of now, I have told you 2 things. Slope is simply tan theta or perpendicular by base, or between the 2 points, it is delta y by delta x, or y2 minus y1 upon x2 minus x1. Now, guys, see. Let's suppose we have got the 2 graphs over here. This graph. This is making an angle of beta. This is making an angle of alpha. Now, in this particular case, you guys are supposed to basically compare the slope of 1 and 2. You guys are supposed to compare the slope of 1 and 2. Can I say in this particular case, here, I can clearly say that alpha is greater than beta. This angle, which first line is making with the x-axis, is greater than the beta angle. If alpha is greater than beta, I can clearly say tan of alpha is greater than tan of beta. Why? Because value of tan depends upon its angle. If angle increases, we say tan theta increases. Okay. Now we know that, sir, we know that tan theta means slope. So can I say from this, I can say slope of line 1 is greater than slope of line 2. Slope of line 1 is greater than slope of line 2. Why? Because angle is more over here in case of 1. Okay, cool. Next. If we have got a line which is parallel to x-axis, can I say here, theta is equal to 0 degrees? Why? Because if the line is parallel to x-axis, means it is making the angle 0 degrees. So if this line is making 0 degrees, so can you tell me what is the value of tan of 0? That is also 0. If tan 0 is 0, we know that, sir, slope is simply that is tan theta. And if tan theta is 0, we say slope will be 0. And it is logical over here. It is having no slope. It is a straight over here, parallel to x-axis. It is having no slope. Okay. Now, sure. How much angle is being made? We say theta is equal to 90 degree in that case, in this case. If the value of theta is 90 degrees, I can say over here in this particular case, we say tan of 90 degree is infinite. And if tan 90 is infinity, so I can say slope in this particular case is also infinite. So means this is having the infinite slope. If angle is 90 degrees, its slope is extremely huge, infinite. We cannot define its slope. Great. Next. Come over here. Now we will be talking about, we say positive slope and negative slope. Let me talk about the positive slope and negative slope. I'll just write over here positive slope, okay, and I'll write over here negative slope. Let me make you understand what is positive slope and what is negative slope. Everybody of you listen to me very carefully. Guys, let's suppose I'll make over here x-axis. Let's suppose I'll make over here, this is y-axis and this is x-axis. This is y-axis and this is x-axis. And if I'm saying the graph is something like this. Next case, over here, this is y-axis and this is x-axis. And in this case, I am saying the graph is, let's suppose, something like this. Here graph is like this, here graph is like this. And in this particular case, clearly we can see this angle is less than 90 degrees. Guys, remember this. I'll tell you, and every question will be solved. If we say theta is less than 90 degrees, okay? Open the trigonometric table and check value of tan theta will come out to be positive. If theta is less than 90 degrees, all the values of tan theta in that case will be positive. Like, sir, tan 60 is less than 90. So tan 60 is positive, root 3. Tan 30, 1 by root 3, positive. Okay, tan 25 degrees, tan 30 degrees, tan 40 degrees. So if the angle is less than 90, we said values of tan will be positive. Check out in the trigonometric table. All tan 67, tan 90, tan 85, all of these values will be positive. Why? Because theta is less than 90 degrees. If value of tan theta is positive, can I not say slope in that cases we say, sir, positive? Yes. So I call this as a positive slope. This has got the positive slope. Why? Because here theta is less than 90. Here, value of tan is less than 90. Guys, do you all agree with me? Tell me in the chats, everybody out there. Let me know in the chats. Do you all agree with me? Do you all agree with me? Do you all agree with me? Let me know in the chats, guys. Let me know in the chats. Everybody means everybody. Yes. Now let's talk about this particular case. Let's talk about this particular case. We say here, if you check value of this angle, we say it is greater than 90 degrees. And in this particular case, we say if theta is greater than 90 degrees and theta is less than, if theta is greater than 90 degree and theta is less than 180 degrees. 180 means this. So if here theta is less than 90 and theta is greater than, theta is greater than 90 and less than 180. In that particular case, we say tan of theta is negative. Values of tan will be negative, like tan of 120 degrees, negative. Tan of 135 degree, its value is negative. Tan of 170 degree, it is negative. So if theta is greater than 90, less than 180, in that case, tan theta will be negative. If tan theta is negative, I can clearly say in that case, slope will be negative. Why? Because tan theta means slope. If tan is negative, slope will be negative. Okay, great. So that's mentioned exactly over here. We said this has got the negative slope. Now, let's suppose if you have got a line something like this. If at this particular point, it is making the angle alpha with the x-axis. Listen to me very carefully. Can I not say at this point also it will make the same angle with the x-axis alpha? Because here also it is making the same angle, here also it will make the same angle. So at every point, this straight line makes the same angle with the x-axis. Slope at every point is same because theta is same. If this is same, angle is same, we say slope in case of a straight line will be same at every single point. So slope at point P is equal to slope at point Q is equal to slope at point R is equal to slope at point S. I hope you are loving this particular session. So I would want you guys to show me the love by liking this session and putting up the fire emojis in the chats. Everybody. Next. Let's talk about parallel lines. If we have got something like this, one line, another line, don't you think that if here it is making the angle alpha, we say here also it will make the angle alpha, here also it will make the angle alpha. We say these angles are same at every point with the x-axis, So if these angles are same, don't you think that tan of alpha will be same at every point? So I can say slope will be same over here. So I can write in this particular case, we say slope of first line is equal to, we say, slope of second line is equal to, we say, slope of third line. Slope of this is equal to this is equal to this. So slope at every point will be same. Why? Because they are making the same angle with the x-axis. Let's talk about these four cases. Guys, see. Here. This is y-axis, this is x-axis. And the line is something like this is the graph. You have to check the value of theta with the x-axis. In this particular case, this theta is less than 90 degrees. You have to check this angle, smaller angle over here. Don't say I'll check this angle, sir. No. So we say theta is less than 90 degrees. If theta is less than 90 degrees, guys, understand one thing. Can I not say in that case slope will be positive? We say slope we also represent with m. Here, slope is m. So if theta is less than 90, we say slope will be m. We say slope will be m. We say slope will be positive. M in that case will be positive. M in that case will be positive. M in that case will be positive. Okay. Okay. Next. Okay. Next, we say, and what is this C? C means where it is cutting the y-axis. We say, sir, it is positive at positive point. So that's why C in this case, this is intercept. So here it is positive. If it would have, like over here, C is negative. Now tell me in this particular case, if the line graph is something like this, we say here in this particular case, we say theta is greater than 90 and less than 180. In that case, we say slope will be negative. Slope will be negative. Come over here. If the graph is something like this, now with the x-axis, it is making angle theta is greater than 90 degrees. So we say here slope will be negative. Here slope will be negative in this particular case. Last one. If let's suppose this is y-axis, x-axis, the graph is something like this. And in this particular case, you can clearly see that, sir, this is the angle with the x-axis. And theta in this case is less than 90 degrees. We say theta in this case is less than 90 degrees. So I can say over here slope will be positive. Whenever theta is less than 90 degrees, slope in that case is positive. Guys, is this crystalline clear to each and every single student? Let me know in the chats. Let me know in the chats. Let me know in the chats, guys. Everyone means everyone. If it is crystalline clear to each and every single student, let me know in the chats with the fire emojis, Great. Notes will be shared also. Okay. You can join my Telegram channel, that is t.me/YAWARMANZOOR. You can join this Telegram channel, and over here I'll be sharing the notes. I will be sharing the notes in this Telegram channel. You can join this Telegram channel. Next, we have got variation of slope. Guys, I told you in case of a straight line, slope at every point is same. Slope at every point is constant. But, if you check over here, we say this is the graph over here, which is a curve. Okay. Now, guys, first is before this, I would want you guys to understand. What is that? I'll mention over here. This is, let's suppose, y-axis, and this is, let's suppose, x-axis. And let's suppose the graph is a curve. In case of a straight line, you already calculated how to find the slope. In case of a straight line, you already calculated how to find the slope. Now, when it comes to the curve, we say, in case of a curve, let's find the slope. Let's find the slope at a point. Let's find the slope at a point. Okay. See. When it comes to, let's suppose I am taking this particular point over here. How do you find the slope in case of a point exactly over here? See guys. I am saying that you take one more point which is very, very close to it, which is very, very close to it. Okay. Then we can consider this as a straight line over here. We can consider this as a straight line. Okay. Now see guys, if we draw a line over here on this x-axis, let's call this as x1. So this first point is at x1 distance. And this second point is at, we say, sir, x2 distance. Similarly, on this axis, this is at y1 distance. This another point is at, we say, y2 distance. Guys, understand very carefully. In case of a curve, if you have to find the slope at a point, sir, in case of a straight line, you said slope between the 2 points. See, slope between the 2 points is delta y by delta x. And slope at every point is same. So even if you find the slope between the 2 points, that will be same, the slope at every point in case of a straight line. Okay. But in case of a curve, it will be different. In case of a curve, it will be different. How do we find it? If we have to find at one point, I am saying that we say take one more point very near to it. Take one more point very near to it. Okay. Now let me make this line over here in a zoomed view. Let me make this line and we say this will be at some sort of triangle over here. Small triangle. I'll make it over here. This is the triangle. This is the triangle. Guys, see. Previously, I said this first one is at x1 distance. Second one is at x2 distance. Don't you think this will be x2 minus x1? And this perpendicular will be y2 minus y1 in this case. Yes, 110%, sir, in this case, we agree. x2 minus x1, y2 minus y1. Now, here, this y2 minus y1, previously, in case of a straight line, when this y2 minus y1 was very big, at that point of time, I called this as delta y. I called this as delta x. But when this distance is extremely small, I will call this as dy. And I will call this as, we say, dx. So I can say here, we say, sir, slope is tan of theta. Guys, understand very carefully. So we say tan theta is equal to, that is simply perpendicular by base, that is dy divided by dx. So I say this is the slope. This is the slope at a point, in case of a curve, in case of a curve. Guys, please tell me in the chats. And one more thing. What is this dy by dx? I can write over here. This dy by dx is, we say, small change in y. I'll mention over here. We say dy by dx. We say it is small change in y divided by, we say, small change in x. And if I mention over here, delta y divided by delta x, what is this? This is large change in y divided by, we say, large change in x. We say large change in y divided by large change in x. And this is slope at a point. This will be slope between the 2 points. So this is slope at a point. We say this is slope between the 2 points. So if you have to find the slope between the 2 points, that is delta y by delta x. If you have to find the slope at a point, we say that is dy by dx. Guys, is this clear? Please give me the signal in the chats. Please. I would need this signal because it is extremely mandatory, okay? I would need the signal from those students also who never put up something in the chats, but right now I need the indication from you guys that you understood each and every single thing. Everyone means everyone. If there are people watching over here, everyone means everyone. With the fire emojis, with the fire emojis. Great, 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 great. Great, great, great. Awesome, awesome, awesome. Okay. See, let me summarize over here. Let me summarize over here because it is extremely important. If I say I have got this is x and this is y and this is a straight line. Okay. If I am asking you to tell me the slope between these 2 points, you say, sir, in this particular case, slope between the 2 points, slope between the 2 points. So that will be simply, or let's not take the straight line right now, because in case of a straight line, you know, between the 2 points, slope will be exactly equal to slope at a point because slope at every point is same. Let's talk about the curve. Let's suppose we have got the curve over here. Okay. I am taking this point and I am taking this point over here. If I say, what is the slope between the 2 points? Slope between the 2 points. Slope between the 2 points. Understand very carefully. Guys, we say slope between the 2 points will be simply that is delta y divided by delta x. Or you can also say it is also tan of theta. How did you get this? This is x1, this is x2. This is y1, this is y2. So this will be x2 minus x1. This will be y2 minus y1. So that is perpendicular by base. Second. I also told you if we have got y versus x, this is y and this is x. If I say the graph is something like this, and you have to find the slope at this particular point. We say slope at this point will be slope at a point is simply that is dy divided by dx. So that is small change in y upon small change in x. Whatever I said, you can forget that. But these 2 points are extremely important. This slide is extremely important. So remember this directly over here. Between the 2 points, delta y by delta x. At a point, dy by dx. Now. One more thing. Sir, what is this dy by dx? We say this is also what we call, we say rate of change of y with respect to x. Rate of change of y with respect to x. How fast y is changing with respect to x? Sir, is this also slope at a point? Yes, this is also slope at a point. This is also slope at a point. Similarly, one more thing. If I say over here we have got dv divided by dt, we call it, this is a rate of change of v with respect to, we say t. And this is also called slope at a point. I hope you understood this. How fast velocity is changing with respect to time. Like if I say dv by dt is, let's suppose, 20 meter per second. What does it mean? Every second we say dv by dt, or you write it something like this. Let's suppose ds by dt is equal to, this is the rate of change of displacement with time. that is 20 meter per second. Means every second body is covering how much displacement? 20 meter per second. So here rate of change is 20 meter per second. Simply dy by dx is slope at a point. Dy by dx is rate of change of y with respect to x. As simple as that. Guys, is this clear? Is this clear? Is this clear? Yes, yes, yes. Okay. Yes. One more point. One more point. One more point. Let's suppose you have got y versus x graph. The graph is something like this. It's a curve. I am saying that you have to find the slope at this point. See, we know slope at this point will be simply, sir, slope over here will be, I say dy divided by dx. And. What is the exact value over here? Guys, see, take a line and draw a tangent at this particular point. If I say this line is making the angle of, let's suppose theta is equal to, we say 60 degrees. Guys, how do we find the slope at a point? What we do is we take a line and we draw it on the x-axis. And then we check the angle with the x-axis, that is 60 degrees. And we say slope at a point is dy by dx. And we say this is also, we say tan of theta. How much angle it is making over here? That is 60 degrees. So I write tan of 60 degree. So I say that will be root 3. So in this particular case, if you have to find the slope at a point, what will you do? You draw the tangent at that point and check how much angle it is making with the x-axis. That will be the slope at a point, tan of that angle. Guys, give me the signal in the chats. I would want you guys to tell me in the chats if everybody of you understood each and every single thing. This is extremely mandatory. Guys, tell me in the chats. Is this crystalline clear? And did you like this session, guys? Make the like count to 300. Make it 300 plus. Now let's talk about the variation of the slope. See, guys, here we have got this curve. If I say you take this particular point. Now see, this particular point, draw a tangent over here, and here it is making the angle theta with the x-axis. At this point, it is making the angle theta with the x-axis. Now take this particular point, draw a tangent at this point. Here, this line is making the angle alpha. Now, can you tell me which of the angles is more over here, sir? Clearly, this angle alpha is more than angle theta. We say here. I can write here. We say alpha is greater than theta. So I can say, we say tan of alpha is greater than tan of theta. So if tan alpha is greater than tan theta, don't you think that slope at this point, we say slope at alpha is greater than, we say slope at this point B. Slope at this point 1 is greater than slope at point 2. So I'll mention over here 1 and 2. Slope at point 1 is greater than slope at point. Okay, so dy by dx at this point is less than dy by dx at this point. Either you say slope or you say dy by dx at what? At point 1, we say it is greater than dy divided by dx at point. It's one and the same thing because that also represents the slope at a point. Next. Let's suppose I give you the question something like this. This is the point 1. This is point 2. and this is 0.3. Okay. You guys have to tell me in this particular case. You guys have to tell me in this particular case, is the slope increasing or the slope is decreasing? Is the slope increasing or let me tell you something like this. Let me make this figure first. Is the slope increasing or is the slope decreasing? Is the slope increasing or slope decreasing? This is the 0.1, this is 0.2, and this is 0.3. Tell me, is the slope in this particular case, you will have to tell me at 0.1, at which point the slope is more. Guys, see. If you have to find the slope at 0.1, what will you do? You will draw a tangent over here, we say, and then you check how much angle it is making over here. Let's suppose it is θ1. Then you draw the tangent at point B. Okay, then you check how much angle it is making with this one. So we say it is θ2. And then you draw a tangent at point C. We say at point C. So θ3 is 0 degrees. Now tell me, is θ2 greater than θ1? Absolutely not. I can clearly say over here, θ1 is greater than θ2. And that is greater than θ3 because θ3 is 0. So if in this case, we say theta is decreasing, at 1, it is more. At 2, it is less. At 3, it is 0. So I can say over here, we say slope at 1 is greater than, I say slope at 2 is greater than, I say slope at 3. Slope at 1 is greater than slope at 2 is greater than slope at 3. This will be the case. Now let's solve these questions. Let's solve these questions. Guys, see. Let's suppose we have got a graph over here, something like this. We have got a graph over here, something like this. I am saying I have the graph something like this. If I ask you, I am taking one point exactly over here. This is the point number 1. Now, if I draw a tangent, can I say this angle is, we say, sir, theta in this particular case is less than 90 degrees. So we say slope at this point will be positive. Yes, slope will be positive. Then we take this point exactly over here. We say over here, we say slope at this point is, we say 0. Why? Because it is making the 0 degrees with the x-axis. And then if we talk about this particular point, we say here theta is greater than 90 degrees. So we say slope here will be negative. Can I say in the first case, guys, see. Initially slope was positive. Then slope became 0. And then slope became negative. Guys, understand this particular case. Initially slope is positive, then 0, then negative. Can I say slope has basically decreased? Why? First it is positive, then 0, then negative. Means slope is decreasing in this particular case. Do you all agree with me? Do you all agree with me? Something like this. Something like this. I'm saying at this point, theta is less than 90 degrees. So at this point, I say slope is positive. At this point, slope is 0. At this point, we say slope is negative. So what is happening with the slope? First positive, then 0, then negative. So we say in this case, slope is decreasing. Hey guys, tell me in the chats. I would want everybody of you to tell me in the chats. Everyone means everyone. Everyone means everyone. Next question. This one here. Let me make this particular question over here. Let me make it over here. Now, can you tell me if I am taking 3 points? This is the point 1, this is the point 2, and this is the point 3. What is happening with the slope over here? Guys, see. I say draw a tangent over here and check how much angle it is making with the x-axis. We say here, this theta is at point 1. I'll write at point 1. We say theta is greater than 90 degrees and theta is less than 180 degrees. So we say slope is negative. At 1, slope is negative. Similarly, if we say at point 2, can I say at point 2? I can simply say theta is equal to 0 degrees. So if theta is 0, we say slope in that case will be 0. Slope at point 2 is 0. Why? Because this line is parallel to the x-axis. Then at point 3, draw a tangent and this angle is less than 90 degrees. We say at point 3, we say theta is less than 90 degrees. If theta is less than 90 degrees, means in that case slope will be positive. And if slope is positive, so what is happening with the slope? What is happening with the slope? Slope is initially, we say, sir, negative. Then it becomes 0. Then it becomes, we say, positive. Can I say in this particular case, slope is increasing? Can I say sure? Sure. We say slope is increasing. I can clearly say in this particular case, slope is increasing. I can clearly say in this particular case, slope is increasing. Do you all agree with me, guys? Let's talk about this one. Let's talk about this one. This point over here, it is making the angle, we say, sir, let's suppose theta 1. Sure, it is making the angle, we say, let's suppose theta 2. And in this particular case, slope is increasing. Clearly, we can say slope is increasing. Sure, it is exactly like this. Here, slope is decreasing. Here, slope is increasing. Okay. Is this clear, guys? Here, slope is decreasing. Here, slope is decreasing. Slope is decreasing in this particular case. Let me show you these two cases. Let me show you these two cases. The first case is this one. Guys, see, if this is already done, we say, let's suppose at this point, it is making the angle theta 1. At this point, it is making the angle theta 2. Clearly, theta 1 is greater than theta 2. So, slope at point 1 is greater than slope at point 2. Next, which one? This one. Let's talk about this one. Let's talk about this one. See, in this case, this is the graph. If I take this particular point over here, my dear friends, can I say in this particular case, we say it has got some angle. So value of slope will be there. And then at this point, it is making the angle of theta is equal to 0 degrees. Here, let's suppose theta 1. Now. Here at this point, we say slope is 0. We say slope is 0. At this point, slope has got some value. Slope has got some value. Okay. Slope has got some value. So we say in this particular case, what is happening with the slope? Okay. What is happening with the slope? Okay. Sorry. Here. We say here slope is negative. At this point, we say at point 1. We say at point 1, we say slope is negative. And then we say at point 2, we say, sir, slope is 0 at point 2. Now it is going from negative to 0. Okay. And maybe then afterwards, if I say the graph is something like this, it will increase. So we say here, slope is increasing. Because see, initially it is having the value negative, then it is decreasing, it is 0. Maybe it will increase after some time, so means here slope is increasing. I hope you are getting me what I'm trying to say. It is exactly like this case, from negative to 0 to positive. It is like this. So that's why it was mentioned over here. So we say slope is positive, slope is increasing. And here in this particular case, sir, why did you say slope over here is, we say, sir, decreasing? Because here angle is decreasing. At this point, angle is decreasing, angle is decreasing. That's the reason. And slope here is completely in positive. What about this third case? What about this third case? Okay. Decreasing, okay. This is your homework. I would want you guys to think about this, how the slope in this case is decreasing. Next. Let's move on to the concept of differentiation. Guys, is the slope crystalline clear? Is the slope crystalline clear? I would want you guys to tell me in the chats. Everyone means everyone. Now we are starting the differentiation. I would want you guys to tell me in the chats. Is this clear? Everyone means everyone, guys. Great. Now guys, see, I'll make you understand what this differentiation is. What this differentiation is. Guys, see. When it comes to the differentiation, I would want you guys to understand one thing. Let's suppose this car started from this point to this point. Okay? And it has covered, we say, let's suppose 100 kilometers of total displacement. This is delta S. And it took the time of total time delta T is equal to 10 hours. If I ask you, what was the speed of the car from this point A to point B in general? You say, sir, when it comes to the velocity of the car from point A to point B, you say that is total displacement traveled upon, we say, total time taken. Total displacement traveled upon total time taken. As simple as that. As simple as that. Just a second. Okay. It is simply total displacement traveled upon total time taken. And I can write this as, that is delta S divided by delta T. Okay. And you can say this as, this is, what is delta S? Delta S is over here 100 divided by, what is delta T? That is 10. And this speed will come out to be 10, we say 10 kilometer per hour. 10 kilometer per hour. Okay. Yes. Absolutely clear. Now. What if I ask you one thing? Sir, this is the speed of the car. We say this is the speed of the car from A to B. From A to B in general. Means this is what we call the average velocity or average speed. Yes. What if I ask you the question? Tell me the velocity of the car at any particular instant. Like if car started from this point and it reached this particular point, okay? Sir, you are saying that from A to B, velocity in general is 10 kilometer per hour. But I am saying that when car was exactly over here, what was the velocity? What was the velocity? In case of the total, we say average. You said, sir, total distance traveled upon total time taken, delta S by delta T. Sir, what will you do in this particular case if you have to find the velocity at any particular instant? What is the velocity of this car? Guys, let's suppose you are traveling from Delhi to Bombay. So it is not like from Delhi to Bombay, you will keep the speed constant as 100 kilometer per hour. No, sometimes it is 40, sometimes it is 60, sometimes it is 0, sometimes it is 80. So if I say at this instant, what is the velocity? Now, this was the biggest challenge to find the velocity at a point. What we will do is that we introduce the concept of differentiation. Introduce the concept of differentiation. So differentiation will actually help us to find the velocity at a point. See how differentiation said, if from this point to this point, displacement is delta S. If from this point to this point, displacement in delta T. Do one thing. Take a very small point which is extremely near it, such that they are very close, such that it looks like it is just one point. So we say, then calculate this displacement between these 2 points. Consider it very small. Consider it very small. We say, take one more point, very near to it. Very near to it. Now, can you tell me how much is the displacement between the two? You say, sir, that is ds. Why do we call it ds? Because it's extremely small. Why do we call it ds? Because it is extremely small. It is extremely small. And how much time they have taken in covering this distance? That is dt. Now, can we find the velocity? We say velocity at this instant will be, that is ds divided by dt. ds divided by dt. Don't you think we have, sir, seen this somewhere? ds by dt, dy by dx. So this is like slope, sir. Yes. So means. This is, we say this is the velocity at any particular instant. And who helped you to get the velocity? Differentiation. So this was basically given by the differentiation. So now, and can I say this is also called, guys, this is rate of change of displacement with respect to time. Yes, 100%. So can I say in this particular case, so I say differentiation helps us to find the rate of change. Differentiation helps us to find rate of change. So my dear friends, this ds by dt, this is what? Rate of change of displacement with respect to time. How did you get it? Because of differentiation. So if I say dy divided by dx, what is this? This is a rate of change of y with respect to x. How did you get this also? We say, sir, differentiation. Actually, this was introduced by differentiation only. Here. If you go over here, I asked you, slope at a point is dy by dx. How did you get this actually? Sir, we took another small point over here which was very near, and then we got it dy divided by dx. So I can mention over here this procedure we did because differentiation helped us over here. This dy was introduced by differentiation. This dx was introduced by differentiation. So I can say here differentiation helped us to find we say dy divided by dx, that is slope at a point. Either you say rate of change of y with respect to x, or you say slope at a point, one and the same thing. So means I can say my dear friends, differentiation helps us to find rate of change, or differentiation helps us to find slope at a point. Guys, tell me in the chats, please. Do you all agree with me? You understood each and every single thing? You understood each and every single thing? Give me the signal in the chats. Guys, give me the signal in the chats. I'm waiting for your signal. With the fire emojis. Porika is confused since the beginning of the class. I am sorry, I cannot help you at all. Yes, everything will be covered in this session only. Now, guys, remember from now onwards. If I say dy divided by dx, we say it is either you say it is slope at a point, or you say rate of change of y with respect to x, or you say differentiation of y with respect to x. It is one and the same thing. Similarly, if I say over here, we say dv divided by, or we'll mention over here ds by dt. Either you say this is the slope at a point in case of ST graph, or this is the rate of change of displacement with respect to time, or this is the differentiation of S with respect to time. It is one and the same thing. It's one and the same thing. Cool. I hope I made you clear what is differentiation. Differentiation is simply, from the graphical point of view, differentiation is to find the slope at a point first. And from the normal example, in the normal real life cases, differentiation is to find the rate of change. That's it. Next. Now the point is how to differentiate. Sir, you made us understand that what is the meaning of differentiation from graphical point of view, also from this point of view also. Just a second, guys. Hello. Hello. Okay. Now, guys, see. So now the question is, how do we differentiate? This is the question that we have got over here. How do we differentiate? See, See. So let's suppose we have got a function as y is equal to x raised power n, and we have to do its differentiation. Sir, doing its differentiation means what? That is finding the rate of change, or that is finding the slope at a point, one and the same thing. How do we differentiate this? We say power down, we'll take this n down. Then we say x raised power, we say n minus 1, x raised power n minus 1. Power down, power minus 1. Like we say y is equal to, I say x square over here. How do we differentiate this? We say dy divided by dx is simply power down, that is 2 down, x raised power 2 minus 1, power minus 1. And this will come out to be, that is 2. Let's suppose you have got y is equal to x cube. And how do we differentiate it? That is dy divided by dx is equal. We say power down, that is 3x raised power 3 minus 1. So that is 3x square. That is 3x. Okay, done with this. 1 by x. Okay, 1 by x. What is the differentiation of 1 by x? Guys, see. I can write it something like this also. Take this in the numerator. So it will be x raised power minus 1. Because here in the denominator it has got power 1. Now do the differentiation. So differentiation is dy divided by dx. So that will be power down, that is minus 1, x raised power minus 1 minus 1, power minus 1. So I can say over here, this dy divided by dx will come out to be. Now see, this is minus x raised power minus 1, that is minus 2. If you take this in the denominator, so it will be 1 upon this, it becomes over here x raised power plus 2. So it is minus 1 by x square. So differentiation of this is minus 1 by x square. Next, we have got y is equal to root x. Guys, let me know in the chats if everything is crystal and clear. Everyone means everyone. If we have got y is equal to root x, how do we differentiate this? We say, sir, dy divided by dx. This is the differentiation. Guys, see. This root x we can write something like this also. That is x raised power, we say 1 by 2. Because the value of root is 1 by 2. Value of root is 1 by 2. So what I can do in this particular case is power down. So 1 by 2. X raised power, power minus 1. That is 1 by 2 minus 1. 1 by 2 minus 1. Now in this particular case, I can say this is 1 by 2. 1 by 2 minus 1, that will be how much? Minus 1 by 2. X raised power minus 1 by 2. Now take this in the denominator over here. Take this in the denominator because see, 2 minus 1 by 2. So this is 1 upon 2. And if you take this in the denominator, it will be x raised power 1 by 2 plus 1 by 2. In the numerator, it is minus 1 by 2. In the denominator, it is plus 1 by 2. So it will be 1 upon 2. And instead of 1 by 2, I can put over here that is root x. So answer in this case is 1 by 2 root x. 1 by 2 root. Guys, is this crystal and clear? I would want you guys to tell me in the chats. Okay, everyone means everyone. Fast. Let me know in the chats. Great. Guys, hit the like button if you have not liked the session yet. Next we have got the differentiation of the trigonometric functions. Let's suppose you have got a trigonometric function over here, y is equal to sine of x. y is equal to sine of x. Sir, what is the differentiation of sine x? You will have to remember all of these directly. You will have to remember all of these directly. So I say, if y is equal to sine of x, we say differentiation of sine x will be simply cos x. And if I say y is equal to cos of x, we say differentiation of cos x will be simply minus sine of x. I directly remember this as it is. Next, if y is equal to cot of x, differentiation of cot x is minus cos x square of x. If y is equal to cosec of x, we said differentiation of cosec x is minus cosec x cot x. Minus cosec x cot x. Next, if you have got y is equal to tan of x, we say its differentiation dy by dx is sec square of x. And if you have got y is equal to sec of x, we say its differentiation is sec x tan x. Directly you will have to remember this, as simple as that. And if you have y is equal to e raised power x, we say its differentiation is also e raised power x. And if you have log to the base ex, we say its differentiation is 1 by x. Its differentiation is 1 by x. As simple as that. Next. If let's suppose you are getting a question something like this, differentiation of a constant multiplied with a function, like you have got over here y is equal to 5x cube. In this case, you will have to find dy divided by dx. In this case, you will have to find dy by dx. What you are supposed to do is, I would recommend you guys to take this constant out. Okay, it is like this. D by dx of 5x cube. We have to do the differentiation. Instead of y, I am putting 5x cube. Now, what I want you guys to do is take this constant out. So we'll take this constant out. Now, what remains over here? D by dx of, we say, x cube. Now, what is the differentiation of x cube? Power down, power minus 1. So it will be something like this. This is 5. And then differentiation of x cube will be power down, that is 3x. Then power minus 1, 3 minus 1. So it will be simply, that is 5 into 3 is 15. And we have got x, 3 minus 1 is 2. So 15x square. That is 15x square. Similarly, in this case, we say, sir, here, we'll take this 2 out. And what is the differentiation of sine x? Recently, I told you over here, sine x's differentiation is cos x. Differentiation of sine x is cos x. So I'll say this is simply, that is cos of x. So it will be 2 cos of. Next. Let's suppose you are getting a question something like this. Y is equal to 4x cube plus 3 sine of x plus 2. Now we have to find in this particular case, that is dy divided by dx. Guys, what is the first thing we guys are supposed to do? We take the constant out. If we take constant out, what is the differentiation of x cube? Sir, it will be, that is 3x square plus. In this case, sir, we take this constant out, that is 3. And here we say this is sine of x. What is the differentiation of sine x? That is cos of x. Then we say plus. What is the differentiation of 2? 2 is constant. So we say differentiation of constant is always 0. Remember, we said differentiation of constant is always 0. Because if something is constant, it will not change. So differentiation itself means the change. So we say its differentiation is 0. So can I say this will be 4 into 3 is, we say 12 x square plus, we say 3 cos of x. 12x square plus 3 cos of x. Next, addition rule. Addition rule. Addition rule simply means if you have got y is equal to a plus b, like 4x square plus 2x, how you are supposed to differentiate in this particular case? You say dy divided by dx. First, you will do the integration of the differentiation of this one. Then you will do the differentiation of this one. So that will be, for this it is 2 into 4 is, we say, sir, 8x, plus for this it will be, sir, 2x. For this it, sorry, it will be, sir, 2. It will be, sir, 2. Guys, if I say y is equal to 2x, what is the differentiation of this one? I will tell you. We write it something like this: dy by dx is equal to d by dx of, instead of y, I'll put 2x over here. I have told you we take this 2 out. Take this 2 out. This is constant. And then we write, sir, if constant is multiplied, then in that case we take it out. If constant is added, then we consider its differentiation as 0. Like here. This constant is multiplied to sin x. We take it out. This constant is added to the function. Its differentiation is 0. So here, 2 is out, so it will be dx divided by dx. So this and this will cancel, so it will come out to be 2. So that's why we said differentiation of 2x is simply, that is 2. So 8x plus 2. Is that clear, guys? Let me know in the chats. Everyone means everyone. Hit the like button, guys, if you have not liked the session yet. Next. Let's move on to the next one. Subtraction rule. If you have two functions in subtraction, like this minus this, how you are supposed to basically find dy by dx? So dy by dx in this case is, for sin x it will be simply cos of x, then minus. For x square it is power down, x raised power 2 minus 1. So it will be simply cos of x minus, we say, 2x. Cos of x minus, we say, 2x. Next, let's suppose if we say y is equal to, we say, sin of x plus 3 cos of x minus tan of x plus, we say, log to the base e x plus 4x cube. You guys are supposed to find dy by dx in this particular case. Guys, tell me what is the value of differentiation in this particular case. Solve it from your end. I'm waiting for the answer. Solve it from your end. What is the value of differentiation in this particular case? Solve it from your end. I'm waiting for the answer. See, first we are supposed to find the differentiation of sin x. What is the differentiation of sin x? That is cos of x. Then plus. In this case, we take 3 common because constant is multiplied. Then differentiation of cos of x is, we say, minus sin of x. Then we say minus. What is the differentiation of tan of x? See, differentiation of tan x is sec square of x. So I'll put up over here, it is sec square of x. Then we say plus. What is the differentiation of log to the base e raised e into x? So we say it is simply 1 by x. See, recently I told you differentiation of log x. Differentiation of log to the base x, that is 1 by x. And then, what is the differentiation of this one? Sir, 4 constant out. For x cube, it will be power down 3, x raised power 3 minus 1. Now guys, see, I can write it something like this. This is cos of x. Take this negative sign out. So this will be minus 3 sine of x. Then we say minus sec square of x plus, we say 1 by x plus, I can say in this 4 into 3 is that is 12 x square. So this will be the answer in this particular case. Great, great. Some of the people are writing in the chats. That's absolutely great. So we have studied the addition. We have studied the subtraction rule. Now. What we are supposed to do is we'll have to basically study the multiplication rule. We'll have to study the multiplication. We'll have to study the multiplication rule. What does this multiplication rule actually mean? Guys, listen to me very carefully. Let's suppose you have got y is equal to a dot b. Y is equal to a dot b, or a multiplied with b. If you have got y is equal to a multiplied with b, this is one function, this is another function, like. You have got y is equal to, we say sine of x into cos of x. Sure, you can consider this as a, you can consider this as b. So we say they are multiplied with each other. So here we use the multiplication rule. What is that? So their differentiation, if we have to find differentiation, we'll keep this a as it is over here. Then we do the differentiation of b, that is differentiation of b divided by dx, db by dx. Then we say plus. We keep the b in front, this is b. Then we say differentiation of a divided by dx, dA by dx. A dB by dx plus b dB by dA by dx. Now, sure. Let me solve this. So we say dy divided by dx is equal. First, we'll keep the a as it is. Let's keep a as it is. We say this is sine of x. Then we say differentiation of b. What is b over here? Cos x. So I'll write over here that is d by dx of cos of x. That is differentiation of cos of x. Then we say plus. We'll keep b as it is. Let's keep b as it is, cos of x. And then we say differentiation d by dx of a. d by dx of a. That is sine of x. Now do the differentiation in the next step. So we say this is dy divided by dx will be simply. So I'll keep this as sine of x. Differentiation of cos x is, what is the differentiation of cos of x? Minus sine of x. And then we say plus, we say cos of x. Differentiation of sine x is, we say, sir, cos of. So I can write over here, this minus will come out, sine x into sine x is, say, minus sine square of x. Then we say plus cos x into cos x is, we say, cos square of x. So I can write it something like this, cos square of x minus, we say, sine square of x. Guys, do you all agree with me? Is this clear? Is this crystalline clear to each and every single student? Let me know in the chats. Let me know in the chats with the fire emojis. With the fire emojis. One more example is given exactly over here. We say consider this as A over here, consider this as B over here. And if you have to find, we say dy divided by dx, you say it will be simply. So for x square, we say, sir, keep a as it is. We say we'll keep x square as it is. What is the formula? Formula is keep a as it is, differentiation of b. Then plus keep b as it is, differentiation of a. So I'll keep a as it is, x square. Now differentiation of sine x. What is the differentiation of sine x? That is cos of x. Then plus. Keep b as it is. So we say cos of x. Then we say differentiation of a. What is the differentiation of x square? That is 2x. So I'll write over here, this will be x square cos of x plus, keep this 2x in front, 2x, say cos of x. Okay. I forgot to do the differentiation. Okay, fine. Now sine, okay. I made a mistake over here. I'll have to keep sine x as it is. Now it is fine. So x square cos of x plus 2x sine of x. X square cos of x, 2x sine of x, 2x sine of x. Next, we have got the division rule. Let's suppose if you have got a function something like this, y is equal to a divided by b. Like we say y is equal to, we say x square divided by sine of x. In this case, we consider this as a and we consider this as b. What is the formula we use over here in order to find the differentiation? See guys, I'll make you understand. We say in this case, dy by dx will be simply, first, we write the differentiation of a, that is dA by dx. But keep b as it is. We'll keep b as it is. We'll do nothing with the b. B will remain as it is and differentiation of a. Then we say minus. We keep a as it is. Then we do the differentiation of b and divided by b square. Let me show you over here with the example. So in this particular case, if we have to find let's suppose dy divided by dx. So I can simply say, we have to use what? Division formula. What does that say? Keep b as it is. What is b over here? Sine x. So keep sine x as it is. What we are supposed to do? dA by dx. Differentiation of a. A is x square. That is d by dx of, we say, x square. We didn't do the differentiation as of now, but we'll have to do in the next step. Then we say minus. Keep a as it is. What is a over here? That is x square. Then differentiation of b. So we say then d by dx of, we say, sine of x. And we say whole divided by, we say b square. What is b? That is, we say, sine square of x. Now do the differentiation in the next step. We'll keep this sine of x as it is. Then differentiation of x square. What is differentiation of x square? 2 down. X raised power 2 minus 1. 2 minus 1. Then we say minus. We'll keep this x square as it is. Then differentiation of sine x is, we say, cos of x. And then we write over here, this is sine square of x. Now this 2x we take over there. So this is 2x sine of x minus, here it will be x square cos of x and whole divided by, I'll write over here, sine square of x. Guys, tell me, you got this? Let me know in the chats. Let me know in the chats with the fire emojis. With the fire emojis. Let me know in the chats with the fire emojis. I'll give you one more question in this particular case as homework. We say y is equal to, we say log of x divided by e raised power x. Find dy by dx. Find dy by dx. This is the first question. Second is y is equal to, we say cos of x divided by tan of x. Find dy divided by dx. We say y is equal to x divided by a root of x. Find dy divided by dx in this particular case. Okay, or let's keep over here, that is, we say sec of x. These are the three questions which I would give you as homework. Next, chain rule of differentiation. This is the last rule of differentiation and we are done with this. Chain rule of differentiation. This is also called, we say, outside, inside a rule. This is also called outside, inside rule. Outside, inside rule. Guys, see. What does this outside, inside rule says? See. It says that when it comes to the outside, inside rule, it says that dy by dx, if you have to find the differentiation of any function, first, what you are supposed to do is, you basically find the differentiation of outer function. Okay. Then multiply it with the differentiation of inner function. Then differentiation of inner function. We say first you have to find the differentiation of outer function, then you have to find the differentiation of inner function. Like. Here, if you are given y is equal to sine of x square, first in this particular case, you will have, what you are supposed to do is you have to find dy by dx. First, in this case, what you are supposed to do is you have to find what is the outer function. See, in this case, when it comes to the outer function, we say outer function is the whole one over here, that is sine of x square. And when it comes to the inner function, sir, inner function in this case will be simply whatever is in this bracket, and that is, we say x square. Outer function is sine x square of x square. Inner function is x square over here, whatever is over here in the angle. Okay. Now guys, see, how do we find the differentiation dy divided by dx? It says that differentiation of outer function. Sir, what is the differentiation of outer function? Sine of x square. We say, what is the differentiation of sine x? It is cos x. So we say it is cos of x square. If it is x square over here, we'll write cos of x square. Okay. Then multiplied by differentiation of inner function. Sir, what is the differentiation of x square? That is, we say, sir, 2x. Then further we can write, take this over there. This is 2x. And I can write cos of x square. 2x into cos of x square. This is what we call the chain rule. Sir, can we use the chain rule in the normal method, like if we have got y is equal to sine of x? Sir, we know differentiation dy divided by dx for sine x is cos of x. Sir, I would want you to find the differentiation of sine x as cos x using the chain rule. Let me tell you. We say here, when it comes to the outer function is whole, that is sine of x. When it comes to the inner function, we say inner function is in this case x. Now we can say dy divided by dx is differentiation of outer function. So for sine x, it is cos of x. Differentiation of inner function. For x, it is 1. I have told you. So cos x into 1 is cos of x itself. That is given over here. Guys, is this crystalline clear to each and every single student? Is this crystalline clear to each and every single student? Like you have got this. Can we find the value of dy divided by dx in this case? Sir, what is outer function in this particular case? Outer function in this particular case is sine of 4x as a whole. What is inner function in this particular case? Inner function is, we say, sir, 4x. Now, differentiation of outer function. Sir, that is sine of 4x. We can write cos of 4x. And differentiation of inner function for 4x, it is 4. So I can write it simply. That is 4 cos of 4x. Next one. We have to find dy divided by dx in this particular case. We have to find the dy by dx in this particular case. Use the chain rule. First, we have to find the outer function. Outer function is the whole. We say here outer function is, that is 2x square plus 3 whole raised power 4. What is inner function? I can say inner function in this case is whatever is placed inside. So that will be 2x square plus 3. Now guys, if I say you have to find dy by dx, dy divided by dx, what will you say? Differentiation of outer function. Outer function differentiation, this one. Guys, if let's suppose it was over here x raised power 4, what would you have said? Sir, that is 4 down x raised power 4 minus 1. Do the same thing exactly. So I say 4 down and then we write over here 2x square plus 3 over here. Keep this exactly over here as it is. Like assume this is x and then you have got 4 minus 1. So this is the differentiation of the outer function. And then you have got inner function. How do we differentiate the inner function? That is differentiation of this one. So for 2x square, it will be 2 into 2 is, we say, sir, 4x plus for 3, it will be, sir, 0. So I can say over here, this will be 4 into 2x square plus 3. 4 minus 1 is 3. And then you have got 4x over here. Even you can multiply this 4x with this 4. 4 into 4 is, we say, 16x. And then you write 2x square plus 3 whole cube. This will be the final answer. Guys, do you all agree with me? Is this crystalline clear? Is this crystalline clear? Let me know in the chats. Everyone means everyone. Everyone means everyone. Everyone means everyone. Guys, with the fire emojis. Guys, hit the like button. If you have not liked this session, make the like count to 300 plus right now. Right now itself. Let's talk about now double differentiation of y. Let's talk about now double differentiation of y. let's talk about now double differentiation of y. Okay, see guys, what does a double differentiation actually mean? Double differentiation simply means it is differentiating twice a function. You have to do the differentiation twice. That's what we call the double differentiation. See, let's suppose if you have got y is equal to x cube and you have to do its differentiation. You say dy divided by dx will be simply. So we say power down, that is 3 down, x raised power 3 minus 1. So that will be 3x square. Now, I want you guys to redifferentiate it. Differentiate it once again. So we write that something like this, d2y divided by dx2. This is how do we write the redifferentiation. So that will be, we say now for this it will be 3 common, and now for x square it will be 2 down, power down, x raised power 2 minus 1. Now 3 into 2 is, we say sir, 6 into x. 2 minus 1 is 1, so 6x. So I can say double differentiation of x cube is simply, that is 6x. It is 6x. Let's suppose we have got e raised power alpha x. Alpha is constant. Now guys, see, we say dy divided by dx for this is, we say simply e raised power alpha x. Okay, first we'll have to use the chain rule over here. See. Can I do one thing? In this particular case, if I say dy divided by dx, use the chain rule. Guys, see, when it comes to the outer function over here, that is e raised power alpha x. And when it comes to the inner function over here, that is this alpha x, whatever is placed in the power, Now, we say differentiation of outer function. So e raised power alpha x is e raised power alpha x only. Because we know differentiation of e raised power x is e raised power x only. So for e raised power alpha x, e raised power alpha x. Then we write differentiation of inner function. Inner function is alpha x. So can I say for alpha x, it will be alpha only? Because alpha is constant. See. I say it is d by dx of alpha x. Take this alpha out, so it will be dx divided by dx. This and this will cancel, so it will be alpha. That's why it will be alpha. So now put up this over here. So this will be alpha e raised power alpha x. So this is dy divided by dx. Now, if I want you guys to redifferentiate it, that is d2y divided by dx2. Guys, see, again we have to use the chain rule over here. See. When it comes to this, we say outer function in this case is alpha e raised power alpha x. And when it comes to the inner function in this case is, we say that is over here alpha into x. Again, whatever is mentioned over here. Now guys, see. What is the differentiation of this? We say, sir, take this. First, we'll have to do the differentiation of outer function. So that will be, take alpha out. So it will be e raised power alpha x only. Differentiation of outer function. Now the differentiation of inner function. Differentiation of alpha x, it will come out to be alpha only. Now alpha into alpha is, we say alpha square e raised power alpha x. So this will be the double differentiation. Okay. This session will go for 3 hours because I have to finish the integration also. So this will be alpha square e raised power alpha x. Alpha square e raised power alpha x. Okay. Like one more if I give you over here. Let's suppose I say y is equal to sine of x. Y is equal to sine of x. Find, we say d2y divided by dx2. means you will have to double differentiate this particular equation. So I'll write over here, sir, dy divided by dx. First differentiation of sine x is, we say, sir, cos of x. If you redifferentiate it again, so that is d2y divided by dx2. So for cos x, once again, differentiation is minus sine of x. So double differentiation of sine x is minus sine of x. Okay. I hope you are liking the lecture. Somebody is saying, damn teaching, your explanation is marvelous. Thanks, bro. Means a lot. Now, let's come on to the concept of maxima and minima. I have promised I will teach you every single rule of integration and differentiation. That too in one session. Now we have got the maxima and minima over here. See guys, see guys. When it comes to the concept of maxima and minima, I would want you guys to understand one thing. Let's suppose I am taking a graph over here that is between y versus x. I am taking a graph over here that is between y versus x. Okay. And the graph is, let's suppose, something like this. The graph is, let's suppose, something like this. Now, can I say in this particular case, sir, this is the point which is the highest point of the graph. This point is the highest point of the graph. So here we say value of y will be maximum. Value of y will be maximum at this point. We say value of y will be maximum at this point. Why? Because this is the highest point in the entire graph. And if we take a look at this particular point, we say this is the lowest point in the entire graph. So we say here value of y will be minimum. Okay. So we call this as maxima, we call this as minima. Highest point at which the value of y is maximum. Lowest point at which the value of y is minimum is the minimum. Okay. Now guys see. If you basically take this particular point and if you draw a tangent over here, don't you think that this tangent is making 0 degrees with the x-axis? Yes. So can I say slope at this point? I say slope at this point is 0. Why? Because theta is equal to 0 degrees. Similarly, I say slope at this point is also 0. Why? Here also this tangent is parallel to x-axis, so slope is 0. So if I say slope is 0 means dy by dx is 0. Because I have told you, even if you call it dy by dx, you call it slope, you call it rate of change of y with respect to x, it is one and the same thing. So we say dy by dx is equal to 0 in both the cases. Okay. So I'll write over here. See, we say, in case of, I say maxima and minima. We say dy by dx is equal to 0. Even if you take this point maxima, even if you take this point minima, we say dy by dx is 0 at both the points. We say dy by dx is 0. Okay. Now, if in a graph you have to find which point is maxima and which point is minimum, what is the first condition? You check at which point dy by dx is 0, that point will be either maxima or that point will be either minima. Now, how do we exactly find which one is maxima or minima? Let's come over here. Guys, see. Here it is mentioned that, see, after maxima, we say slope is decreasing. Slope is decreasing. Okay. See guys. When it comes to this point, here it is 0, slope is 0. Can you tell me what is the value of slope at this point? It is negative. Obviously, I have told you before, guys, see. We say at this point, slope is, we say, sir, negative. So directly, forget about the slope and all. We say if d2y by dx2 is coming out to be negative, means that is maxima. That is maxima. And if d2y by dx2 is coming out to be positive, we say that is minima. That is minima. Like. Sir, how do we check which one is maxima and which one is minima? Let's take this point. Find dy by dx at this point. If it is coming out to be 0, it can be either maxima or minima. Take this point. Here also dy by dx is coming out to be 0. It can be either minima or maxima. How do we check if it is maxima or minima? Now see. To check, I'll mention over here. To check, we have to find, we say d2y divided by dx2. We have to find double differentiation, double slope. So if we say d2y divided by dx2, if it is coming out to be, guys, listen, if it is coming out to be positive, if its value is coming out to be positive, means it is minima. And if we say d2y divided by dx2 is coming out to be negative, we say it is maxima. We say it is maxima. Example. Let me show you with the example. Okay. So we say, here it is mentioned, for maxima dy by dx is equal to 0, d2y by dx2 has to be negative, means change in slope. dy by dx is slope, d2y by dx is change in slope, double slope. It has to be negative. Next. Question over here. Here we are given as y is equal to x square minus 4x plus 5. Okay. Now guys, we have to find maxima and minima. Let's suppose the graph of this equation is, let's suppose the graph of this equation is, let's suppose something like this only. Okay. We don't know, let's assume. Okay. Now. If I say we have to find maxima and minima, to check maxima and minima, how do we find that? First we check dy by dx. See, we say, sir, in this case, dy by dx is equal to, that is differentiation of this. For x square, it will be 2x. Minus, we say, for 4x, it is 4. For 5, it is 0. Now, guys, see. I say, put dy by dx is equal to 0. Because we know, in case of maxima and minima, dy by dx is equal to 0. dy by dx is equal to 0. So I can say this will be 2x minus 4 is equal to 0. Why? Because I have told you dy by dx is equal to 0 in case of maxima and minima. So listen to me very carefully, guys. So I can say 2x is equal to, I can take this over here, this will be plus 4. So x will come out to be 2. So can I say, we say at x is equal to 2, we got dy by dx is equal to 0. At x is equal to 2, we got dy by dx is equal to 0. So I can say at x is equal to 2, it is either maxima or minima. Like over here, guys. See. We say at x1 in this particular case, we say dy by dx is 0. Means at x1, it can be either maxima or minima. That we will find. Similarly, at x2 also, we say, sir, slope is 0. Dy by dx is 0. So at x2 also, it can be either maxima or it can be either minima. Enough. So we say at x is equal to, it can be either maxima or minima. We don't know. Now, how do we find? So we say to check, let's find, we say d2y divided by dx2. Let's do the double differentiation of this one. So we say d2y divided by dx2 is equal to, what is the double differentiation of this one? For 2x it will be 2, minus, we say, sir, for 4 it is 0. Is this 2 positive or negative? We say, sir, it is positive. And I have told you, if d2y by dx2 is equal to positive, then we say it is, then it is minima. Then it is. So at x is equal to 2, we say it is minima. Why? Because double differentiation comes out to be negative. So I can mention over here. So at x is equal to 2, it is minimum. And if you have to find the value of minima, and also we can find the value of minima. Also we can find the value of minima. See, guys, I can write over here. Guys, what is the value of y? What is the value of y? So x square minus 4x plus 5. So as we say y is equal to x square minus 4x plus 5. Guys, I have told you at x is equal to, it is minima. What is the value of minima exactly? So I say put x is equal to 2 and get y minimum value of y. So I can write y is equal to, put x is equal to, we say 2 square minus 4 into 2, we say plus 5. So this will be 2 square is 4 minus 4 into 2 is 8 plus, we say, sir, 5. Okay. And this will be 5 plus 4 is 9. 9 minus 8 is, we say, sir, 1. So value of minima is 1. Guys, tell me in the chats, do you understood everything? Guys, everybody understood? Let me know in the chats. Everybody means everybody. Let me know in the chats if you understood. So simply, if there is a function given, okay, if they ask you to find the value of maxima and minima, what will you do? First, you will differentiate. So make it equal to 0. So at that point, we say it is either maxima or minima. Then you will have to redifferentiate. If it is positive, it is minima. If it is negative, it is maxima. Okay. We'll just finish this in next 30 minutes. Next 30 minutes and we are done with the entire integration. Let's move on to the integration right now. Just 30 minutes, guys, for what you need the break. Just 30 minutes and we are done with this chapter. You don't want me to finish this particular chapter, okay? You don't want me to finish this particular chapter? Tell me. Next 30 minutes and we are done. And I would want all of you to put up in the chat later on, how was the class? How was the class? Great, 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 great. Yes, 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 I'll continue. I'll continue. Now see guys. Let's talk about area under the curve. What does area under the curve mean? Let's suppose we are given a graph over here, and this is the graph, okay, constant graph, okay, it is parallel to, we say, x-axis. If I ask you to tell me this area under this graph, this area, you say, sir, this is like a rectangle, so its area will be simply length multiplied by breadth. If I say this is over here 10, so length is 10 and breadth is 5, so 10 into 5, that is 50. So here, in this particular case, we can easily find the area of this graph. Now, let's suppose we get a question something like this. We have a curve. And in this case, you have to tell me what is the area under the curve. You have to tell me what is the area under the curve. Area under the curve. What is the area under the curve? Now see, guys. Now see. My dear friends, in this particular case, can I use the rectangle formula over here? Sir, no. Why? Because this is not a rectangle. It's a curve over here. I cannot use this formula to find the area. Sir, can I use the triangle formula to find the area? No, because it's not a triangle. What will I do? I'll do one thing. I'll take a small strip over here. This is infinitely small. Okay. I'll mention, we say, let's take a small strip. Let's take a small strip and find its area Let's take a small strip and find its area. We say, let's suppose the length of this is, we say, sir, y, and this width, if this is x, we say obviously it will be dx. It's very small, infinitely small width, so it will be dx. So can I say its area will be small, that is dA is equal to, now. Don't you think that this infinitely small strip behaves like a rectangle? Yes. So for rectangle, we can basically use the formula length multiplied by breadth. So I can say over here, dA is equal to y dx, length into breadth. This is the area of the small strip. Similarly, I will take one more area over here. We will find its area also, that will come out to be dA. So we say area of this is also dA. Similarly, one more strip over here, its area is also dA. So we are basically cutting this in infinite number of strips. Okay. Now guys see. We say, now cut this area in infinite. infinite strips and find their area. Now afterwards, and add them, guys. If you got the area of all those strips, dA, 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 and you have to add all of those, what will you do? Sir, I'll use the summation. No, that will not work over here. Why? Because these are the infinite quantities. So we use integration. So we use integration to add them, because integration helps us to add the integration helps us to add the infinite small quantities. So I can say, so to get the total area, I can say integration of dA. What does this mean? This is the addition of all of those areas. It will be simply integration of, that is, y dx. Can I say integration dA, 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 dA? It will give me the total area total. It will be integration of y dx. Integration of y dx. Guys, is this clear? This is basically the area under the curve. So simply you say the area under this curve will be integration of y dx. So I say integration helped us to add the infinite number of quantities, infinite number of small quantities. Okay. So integration helps us to add infinite number of small quantities, and differentiation helps us to find the rate of change. Now guys, come over here. Now the question is, we understood what is the meaning of integration. Now the question is how to integrate. Like we understood the meaning of differentiation, then afterwards I told you how to differentiate. Same is the case over here. Let's suppose you have got y is equal to x raised power n, and you have to integrate it. We write it something like this: integration of y dx. This means integration of y. So we write integration of, we say instead of y we put x raised power n, because y is equal to x raised power n. Now do the integration. So we say it is x raised power n plus 1 upon n plus 1, power plus 1 upon power plus 1. Ignore these as of now. I will tell you after some time. Like you have got over here. Let's suppose you have got over here, we say y is equal to x cube, and you have to do its integration. Means you have to find integration of x cube dx. What is the integration of x cube dx? We say it will be simply x raised power plus 1, that is 3 plus 1 upon power plus 1, that is 3 plus 1. So it will be simply x raised power 3 plus 1 is 4 upon, we say 4. If I say y is equal to, I say x raised power 36. What is the integration of this x raised power 36? And then we say dx. This is the integration of this. Now do the integration. So we say x raised power plus 1, that is 36 plus 1 upon 36 plus 1. So it will be x raised power 37 divided by 30. If I say y is equal to, that is 4x cube, what is the integration of this? 4x cube, and then we say dx. Now, always remember, guys, we take this constant out of integration as well as out of differentiation. So take this 4 out. Now it will be simply for x cube, it is x raised power. We say 3 plus 1 upon 3 plus 1. So it will be simply that is 4 and it will be x cube, sorry, x raised power 4 divided by 4 over here. 4 and 4 will cancel, so it will be x. And always remember, we say it is plus c, we say it is plus c, we say it is plus c. We always add the constant over here. We always add the constant over here, plus c, plus c, plus c. So remember, so we say over here also it is plus c. It is plus c. Okay. Is this clear? Next. Next. Let's suppose you have got this. In this particular case, you guys are supposed to find, we say, integration of x dx and x raised power 3 by 2 dx. How do we integrate this? We say it will be simply x raised power plus 1, that is 3 by 2 plus 1 upon 3 by 2 plus 1. Now, can I say this will be x raised power? 2 into 1 is 2, 2 plus 3 is, so we say 5 by 2 upon, we say 5 by 2. And do the reciprocal, so this will be 2 divided by 5, x raised power 5 by 2 plus c. Is this clear? Is this clear? Now, one more thing over here. So we say here integration of this is 3 root x. It is something like this. This is cube root of 3, cube root of x dx. Okay. Always remember, guys, it is something like, understand one thing. If cube is mentioned over here, 3 is mentioned over here, always remember this is cube root. So it is x raised power 1 by 3. Value of this root is x raised power 1 by 3. If it was square root, only root x, so it was x raised power 1 by 2. So that's why we call it the cube root. We call it the cube root. Now, how do we integrate this integration dx? So we say it will be simply x raised power plus 1, 1 by 3 plus 1 upon 1 by 3 plus 1 is equal to, so this is 3 into 1 is 3, 3 plus 1 is 4. So it will be x raised power 4 by 3 upon 4 by 3. So now do the reciprocal of this, it becomes 3 by 4 x raised power 4 by 3 plus c. Plus c. Next, let's talk about, yes, indefinite integration. Let's talk about integration with limits. Integration with limits. See, guys, what is the meaning of integration with limits? Come over here. First, I'll make you understand in the graph. I asked you, you have to find the area under the curve. I asked you from where to where. Sir, this point is at x1 distance. This point is at x2 distance. So you have to find the area from x1 to x2. That's what is the meaning of this one. So these are what we call the limits. Means from where to where you have to find the area. If I say here it is x3, here it is, let's suppose it is x3 and x4. From x3 to x4 you have to find it something like that. Okay. That is what we call the integration with limits. These are called the limits. Now, that I will show you over here. Let's suppose if a question is given something like this. Integration of 4x plus 2 dx, and here it is 0 to 2, it will be equals to. So means you have to integrate this over here. You have to do the integration of this term over here. You have to do the integration of this term over here. See guys, I'll make you understand. First, you do the normal integration. That is, what is the integration of 4x? Guys, understand very carefully. Understand very carefully. So I say integration of 4x dx. We take this 4 out, integration x dx. So that will be 4. Integration of x will be x square divided by 2. Power plus 1 upon power plus 1. Something like this. So here, okay, forget about this plus 2. I'll directly write dx. The next question I will show you. So integration of 4x will be simply take this 4 out. So it is integration of x dx. From where to where? We say from 0 to 2. And it will be, we say, sir, it is 4. Then we say integration of x. So it will be x square divided by 2 from 0 to 2. Now guys, understand one thing. So we say 2 1s are 2 2s are 4. So this will be 2x square. And limits are from 0 to 2. Now what do we have to do with the limits? Guys, understand. First you put the upper limit like this. Take this 2 out. In this x, you have to first put the upper limit. That is 2. Instead of x, you put 2. And here it is square, so 2 square. Minus. Then you put in this x as lower limit, that is 0. So this will be 2 square is 4. 4 into 2 is, we say, sir, 8. So value of integration of this is, we say, sir, 8. Over here it is 8. Similarly, if I let's suppose say integration of 4 minus x square. 4 minus x square, and we say, sir, dx. Let's suppose 4 plus x square dx. So 0 to 2. What is the value of its integration? If this is the question. Guys, understand one thing. Guys, understand one thing. Tell me the answer in the chats. Guys, understand this. Understand this. We say in this particular case, first we have to do the integration of 4. See guys, let's suppose I say you have got integration of 4 and this dx. Always remember, integration of constant will be, take this constant out. Then you have integration of dx. Always remember that we cancel this and this. Always. Don't ask me why right now. We say it will be simply that is 4x. Because this and this will cancel, it will come out to be 4x. Okay. Like we say integration of 8 dx. It will be simply take this 8 out, integration of dx. This and this we cancel, so it will be 8x. Integration of 2 is 2x. And if I say integration of 4 dt, in this case, you take this 4 out, integration dt, this and this will cancel, so it will be 4t. Okay. Now here, we say integration of 4, it will be simply, sir, that is 4x plus integration of x square. Sir, we have got x square dx. How do we do the integration? So x raised power 2 plus 1 upon 2 plus 1. That is x cube divided by 3. I'll write over here x cube divided by 3. And limits are from 0 to 2. Limits are from 0 to 2. So can I say over here? Now, first put the upper limit. So we say x4 into. In this x, you have to first put upper limit. That is 2 minus. If it was 1 over here, you would have to put 1 in that case. But it is 0, so 2 minus 0. Then we say this plus. Then we say x. So I'll write this, I'll take this 1 by 3 as common. Now, in this x, you have to put first 2, so it will be 2 cube minus. Then you have to put 0 over here, so it will be 0. Now 2 minus 0 is 2. 2 into 4 is, we say, sir, 8 plus. 2 cube is 8. So we say this is 8 divided by, we say, 3. Now 3 into 8 is, we say, sir, 24 plus, say, 8 divided by 3. Guys, you understood this? Let me know in the chats. Okay. Now how much is this? 24 plus 6 is 30. 32 divided by 3. 32 divided by 3. Okay. Why are you saying 8? 8 is not the answer over here. (32 by 3 is the answer. Let's suppose I give you the question something like this. This is your homework. This is your homework. Integration of, we say, x square plus 2x plus 1. It is from 1 to 3 and dx. You have to get the value of this and put up the answer in the comments later on. Put up the answer in the comments later on. Next. See, guys, let's now talk about the integration of, we said, trigonometric functions. Let's now talk about the integration of trigonometric functions. Integration of trigonometric functions. Guys, see, always remember, see. I'll make you understand certain thing. A question. What is that? We say integration is the reverse process. A reverse process of differentiation. We say integration is just the opposite of differentiation. I'll tell you how. See. Let's suppose we have got y is equal to x square. You see the beauty right now, guys. You see the beauty. We have got y is equal to x square over here. If I want you guys to find its differentiation, dy by dx, what is that? Sir, power down to x raised power 2 minus 1, and that is 2x. This is how do we find the differentiation. Now, I want you guys to take this 2x and do the integration. Take this 2x, integration of 2x, and we say, sir, dx. We say, sir, dx. Now, what is the value over here? We say take this 2 out, 2 is common, integration of x, we say, sir, dx. So can I just write this is 2? Integration of x will be what? We say, sir, that is x raised power 1 plus 1. 1 plus 1 upon 1 plus 1. So that will be 2x square divided by 2. 2 and 2 will cancel, so it is x square. So once again, we got the value back, which was the original value. So I can say integration is just the reverse process of differentiation. If you have got x square, you find its differentiation. And if you do its integration, it will give you back x square. So that's the reason we say integration is the reverse process of differentiation. Next, see, guys. Now, if integration is the reverse process of differentiation, if I, let's suppose, say y is equal to sine x, okay? What is the differentiation of sine x? We have already studied, it is cos x. Differentiation of sine x is simply cos x. Now, guys, see. If I ask you, if you integrate this cos x, okay, don't you think that you should get this sine x back? If y is equal to sine x, and integration of sin x is differentiation of sin x is cos x. Now, if you integrate this cos x, you should get back this sin x. Yes, 110%. Now see. If I say y is equal to sin x, its differentiation is cos x. Now, if you integrate cos x, we say it will come out to be sin x back plus c is the constant. Similarly, if I say y is equal to cos x, its differentiation is minus sin x. Now do the integration of sin of x. We say its integration will be minus cos x. Or if you place a minus over here, so integration of minus sin x is cos x. Take this next over here, it will be minus cos x. Similarly, we say y is equal to tan x. Differentiation of tan x is sec square x. Now do the integration of sec square x. Integration of sec square x will give you the tan x back. Similarly, we say y is equal to cot x. We said differentiation of cot x is minus cos x square x. Now do the integration of minus cos x square x minus cos x square x. It will give you the cot x back, and take that minus, place it over here. So minus cot x. Guys, you are understanding this? Guys, please tell me in the chats. With the fire emojis, is this crystal and clear? Tell me in the chats. I need the signal from you guys. I need the signal from you guys with the fire emojis. Everyone means everyone. Everyone means everyone. And if you have not liked the session, I would want you guys to like the session as soon as possible. Now, we say y is equal to sec x. We said differentiation dy by dx of sec x. It will be simply, sir, sec x plus tan x. That is differentiation. Now do the integration of this. Integration of sec x, tan x, and over here multiply with dx. So it will give you back sec x. Similarly, y is equal to cosec x. Differentiation of cosec x is minus cosec x cot x. We say integration of this will give you minus cosec x. Okay. If y is equal to e raised power x, we say differentiation of e raised power x is e raised power x. Now, do the integration of this e raised power x, it will give you e raised power x back. So integration as well as differentiation for e raised power x is e raised power x on. Next. We say y is equal to 1 by x. We say, okay, y is equal to log of x. We say differentiation of log x is 1 by x. Now do the integration of 1 by x. It will give you the log x back again. Okay, great. I know you guys are loving this session. All the sessions will be like this only. You don't have to worry about anything. I will finish each and every single chapter. That is my guarantee. Okay. Next. So we say this is done. Okay, let's find the value of this one. Integration of sine theta t theta from 0 to pi by 2. Okay, see. If I ask you what is the integration of sine theta? Integration of sine x is, we say, minus cos x. If it is integration of sine theta, it will be minus cos theta. So I can put up the same thing exactly over here. We say integration of sine theta, it will be simply, that is cos of theta. Okay, and the limits are from 0 to pi by 2. Pi by 2 means 90 degree. Now see guys, put up the upper limit. We put the upper limit first. So we say it is cos of, instead of this theta, I'll write pi by 2 minus. Then we say cos of, we put the lower limit in theta, that is 0. Now, can I say over here, cos pi by 2, that is cos 90. Cos 90 is 0 minus cos 0 is 1. So, answer in this case is, guys, is this clear? Is this clear? Next, this is your homework. Pi means 180 degree. It means 180 degrees. So, this is your homework. This is your homework. I have already shown you this. Let's suppose if you have a constant multiplied with a function and you have to do its integration. Integration of 2 sine of x and then we say dx. Then we say dx. What we used to do in case of differentiation, we used to take this constant out. Here also we'll take the constant out. Then we say integration of sine of x dx. Now here, this is 2. Integration of sine x will be simply minus cos x. Minus cos of x. So it will be simply minus 2, we say cos of x plus minus 2 cos of x plus c. Addition rule of integration. Let's suppose if you have got y is equal to a plus b, how you are supposed to integrate all of these? Like. I say, let me give you an example. Y is equal to x square plus sine of x. Here this is a and here this is b. How you are supposed to integrate these functions? It is easy. So we say integration of y dx will be integration of x square plus sine of x and then we say dx. Now do the integration separately. I can say for x square it will be x cube divided by 3. Now plus, what is the integration of sine x? We say, sir, that is cos of x minus cos x. So it will be simply that is x cube divided by 3 minus, we say, cos of x. Similarly, this is your homework. And this is also your homework. I'll do it here only. So integration of, we say, sine of x plus e raised power x plus 1 by x and then we say dx. Now guys, see, integration of sine x will be simply minus cos of x. Then plus integration of e raised power x is e raised power x on. And integration of 1 by x is log to the base e raised power x. See, integration of 1 by x. Integration of 1 by x is ln of x or log to the base e x. So I can say over here, okay, done. Then we add over here plus c. I will be sharing the PDF over here in this Telegram channel. That is t.me/Yawar YAWAR MANZOOR. Here PDF will be available. Notes. Now we have got, that's what we call the outside inside rule. That's what we call outside inside rule. Like this is what we call the chain rule of integration. Okay. What does this rule actually say? Like what was the chain rule of differentiation? That was differentiation of the outer function multiplied by the differentiation of inner function. But when it comes to the chain rule of integration, it is simply, if I say integration of y dx, it is simply integration of outer function multiplied by the coefficient of x, multiplied by the coefficient of x. Like. If you are given a question something like this, we say integration of cos of 2x, okay, dx. Guys, understand very carefully. Here, if I ask you what is the outer function, what is the outer function? You say simply it is cos of 2x. What is the coefficient of x? The coefficient of x is 2 over here. I say coefficient of x. Two over here. Now let's do the integration of this one. Let's do the integration of this one. I can write the integration of outer function. So outer function is cos of 2x. What is the integration of cos x? Let's go over here in the table. We say integration of cos x is sine of x. Integration of cos x is sine of x. So I'll write over here. For cos 2x, it is sine of 2x divided by. What is the coefficient of x? The coefficient of x is 2. So I said divided by 2. Next, e raised power 5x. So we have to find integration of e raised power 5x dx. See, if I ask you what is the outer function in this particular case, you say, sir, e raised power 5x only. And what is the coefficient of x? You say, sir, that is 5. That is 5. Now tell me, sir, integration of this one. What do we do? Integration of the outer function. So for e raised power 5x, it is e raised power 5x only. Why? Because e raised power x has got the integration of e raised power x only. Divided by coefficient of x is 5. Similarly, if I say y is equal to e raised power 36x. So what will be the integration of this? Integration of, we say e raised power 36x dx. That will be simply e raised power 36x divided by 36. Next, let's suppose you have got this question. So in this case, if I talk about the outer function, that is sine of 2x plus 4. 2x plus 4. And if I talk about over here, the coefficient of x, sir, that is 2, coefficient of x. Now let's do the integration of this one. So I say integration of this one will be simply integration of the outer function. So outer function is sine of something. So it will be simply minus cos of 2x plus 4. Because we know integration of sine is cos. Divided by, what is the coefficient of x? That is 2. So this will be, and you say over here plus c. Here also plus c. Next, here we say in this particular case, if I talk about the outer function is cos of 4 minus 3x. If I talk about inner function, we say that is simply 4 minus 3. Now, let's find the integration of this one. That is integration of outer function, cos. So it will be sine of 4 minus 3x. And what is the coefficient of x? Sorry, inner function we don't have to talk about over here. We have to talk about coefficient of x. Coefficient of x over here is minus 3 because it is minus 3. So that will be divided by minus 3. Next. Now, here we say, in this case, it will be integration of outer function. Outer function in this case is e raised power minus 3x. So it will be e raised power minus 3x divided by. Coefficient of x, that is -3 over here. This I'll give you as homework. Comment down the answer. So when I end the live stream afterwards, you will have to comment down its answer in the chat, in the comments. And guys, with this, we are done with this particular session, and I want you guys to basically let me know in the chats how was the session. Okay, open your heart and write a beautiful comment out there and let me know in the chats how was the session. Okay, in the comments later on, not in the chat, in the comments later on when I end the live stream. Not right now, in the comments. Okay, each and every, because we keep on seeing your comments and that motivates us, and that's the reason every time we come up with the live sessions like this. Now let me just tell you, my dear friends, there is a big surprise that is basically coming up, big reveal. That is Unacademy Learning Festival. That is 7 days free unlimited access to NEET UG Plus subscription. So means you have to pay nothing in order to basically take this plus subscription for 7 days. Okay, so online, live and recorded batches. Okay, doubt solving, you have study material created by top educators, everything. You don't have to pay anything, just you have to basically, link is in the description below, you have to enroll and you have to enter. Okay, and if it asks for the code, you can use my code, that is YAWAR. Okay, so it will be completely free of cost. You can basically enroll in this one. And one more thing is that we have recently started the Phoenix 3.0 batch. Even you can watch the lectures of the Phoenix 3.0 batch also, completely free of cost. You don't have to pay anything. Okay, just use my code. The link is in the description below. Click on to that link and enroll and enter into this batch completely free of cost, which has started already today only. So thank you so much, guys. This was all about it. I would want you guys to put up in the comments later on, okay, and let me know how was the session with your heart. Every comment should be there. So take care and bye-bye. Thank you so much. See you guys very soon. Take care.